Alright, this is HIV/AIDS Part 2. The part that we're on to now is how to diagnose HIV. And just because somebody is diagnosed as having HIV infection does not mean that they have AIDS. That's a different definition that we'll talk about in a second. The way that people are diagnosed with HIV is through either testing that detects the virus itself or testing that detects the antibodies to the virus. Some types of tests that are done are ELISA, which stands for enzyme-linked immunosorbent assay, latex agglutination, or the rapid antibody tests. The one test that isn't on here is what we call a confirmatory test. That's called a Western blot, and that looks for the specific antibodies against HIV. I mentioned that AIDS is a different diagnosis. Again, somebody has to test positive for the virus first, but on top of that, there are some other tests that are done in order to meet the criteria of AIDS. AIDS is a more serious version of HIV. That means that the immune system has started to wane. So one of the things that we do to test for AIDS is look at the CD4 count. Now, CD4 again is that receptor that's on the outside of helper T cells. So in this test, we are looking for helper T cells that carry that CD4 receptor. And if you find fewer than 200 cells per microliter of blood, that is considered AIDS. Now, those helper T cells should be in much higher proportion than that. Also, if your CD4 cells, if the helper T cells account for fewer than 14% of all of the lymphocytes, then that's also considered AIDS. And that is, again, a very low proportion. Another thing that could be a criteria for AIDS would be is if a person with HIV has an opportunistic infection that's on the CDC's list of AIDS-defining illnesses. An example of that would be Kaposi's sarcoma, pneumocystis pneumonia, or even tuberculosis. Treatment for HIV, I want to be clear about this. There is treatment for HIV, but there is no cure for HIV. Okay, so right now, there's no real cure that's ever been documented for HIV. The treatments that are available can slow down the progression of the disease, keep it under control, but will never get rid of the virus itself, not the way that they are right now. Treatments that are available for HIV are antiviral medications that affect HIV at various points of its what we call life cycle. And again, viruses aren't alive, they're active or inactive. But there is a distinct cycle to viruses, how they replicate and are able to go on and infect other cells. The types of drugs that are used to treat HIV are reverse transcriptase inhibitors. Again, that's an enzyme that allows RNA virus or retroviruses to turn their RNA into DNA. Protease inhibitors and integrase inhibitors, and we'll talk about what those are when I show you this next picture. Generally, a treatment regimen includes multiple drugs that affect multiple steps in the life cycle. So we call that kind of a cocktail. One drug is not enough. The virus can mutate and change to become resistant to that one drug. But if you hit the virus with a drug from each of those three categories, it's incredibly rare, incredibly hard for that virus to mutate enough and survive long enough in order to become resistant to all three of those drugs. So these are the different parts of the so-called life cycle that the different drugs can interfere with. This is our reverse transcriptase inhibitor. Now what these drugs do is they act as an analog to a nucleotide. So they get in there into the reverse transcriptase and they act as a competitive inhibitor to block it from working. These are the protease inhibitors, and one of the things about that's unique about HIV is that before the proteins that are involved in the HIV virus, before that they can be put together to make a mature virus that can go on and infect other cells, some of these proteins need to be broken down. And when proteins are broken down, they are broken down by enzymes called proteases. And HIV has specific proteases that break down those proteins. So these inhibitors block the proteases from doing their job. The proteins cannot become mature, and therefore the virus cannot become mature and infect other cells. The final type are integrase inhibitors, and what they do is they prevent the viral DNA, so that's the RNA that was turned into DNA, they prevent that from integrating into the host DNA. So the viral DNA can't get into your genome. Now, because HIV is not curable, only treatable, the best way to get rid of HIV infection is to just not have it at all. So prevention with HIV is key, again, because there's no cure. Ways that we tell people to prevent infection with HIV is of course, avoid sexual contact with those people that we know have HIV. And if it's unavoidable, try to use barriers like condoms, okay, every single time. Especially if you don't know the status, the HIV status of the person that you're having sexual contact with. Not sharing needles, so intravenous drug users, for example, should have clean needles, or they should be disinfected before using them. A woman who has HIV should tell her doctor if she becomes pregnant, or before she becomes pregnant, because babies born to HIV positive mothers should receive a regimen of antiretroviral drugs as soon as they're born. And some of these drugs are actually safe for women to use while they're pregnant to help prevent passing the virus on to the baby. Right now there are 30 potential HIV vaccines in clinical trials. So there's 30 potentials out there, but there are none on the market yet. And most of the vaccines that have come along and been tested have not worked. HIV is a serious problem. The epidemic that we're currently facing began in the 1980s. Since then, 60 million people worldwide have become infected, and 30 million have died of HIV-related causes. So either from that waning immune system or opportunistic infections. So let's just put that in perspective. 60 million people have become infected, and half of them have died. And it's estimated that right now, currently in the world, there are 34 million living people with HIV. Each, in the United States alone, there are 1.1 million infections. Each year, for example, in 2011, there were 2.5 million new infections worldwide. So 2.5 million people became newly infected with HIV in the world in 2011. This is showing you the prevalence rate of HIV over the United States. I've shown you this graph before previously in the epidemiology section. But again, this is prevalence. So this means that these are people that currently are living with HIV. These are not new diagnoses. These are new diagnoses and old ones, all people living with HIV, broken down by state. The darker the color, the higher the rate. And again, the rate means that this is how many people per 100,000 in the population have HIV. So for Illinois, it's 300. There are 300 people living with HIV for every 100,000 in the population. What this is showing you are the different ways that people have acquired HIV infection, okay, and how many, the estimated number of diagnoses in 2010. So as you can see, most of the people that acquired HIV in 2010 acquired it, we think, between by male-to-male sexual contact. Injecting drug use is also a major way that people can acquire HIV. But if you see here, heterosexual contact is also a major way to acquire HIV. Okay, so just because you're not gay doesn't mean you can't get HIV. Anybody can get it. This is showing you the mortality rate due to HIV infection over the years. Again, the epidemic started in the 80s, and as the epidemic took hold, we started diagnosing more and more people with HIV. You can see the number of people dying from HIV went up. This number, again, is the rate per 100,000 people in the population. But then in the mid-90s, we started developing drugs that are effective against HIV and understanding how to prevent it as well. So the mortality rate, the number of people dying because of HIV, dramatically goes down. And now we're to a point where people still have HIV, people are still dying from HIV, but it's a manageable disease if people take medications properly and if we can prevent the spread of the infection to other people. Now you might be asking yourself, where did HIV come from? Okay, if the epidemic just started in the United States in the 1980s, where in the world did it come from before that? Where was it? Well, one of the ways we know where a disease came from is by looking at areas of the world where there is the most genetic diversity among the virus or microbial strains. And in the case of HIV, if you look at people from Central and Western Africa, you'll find that their viruses, the HIV virus that they have, is the most genetically diverse. They have the most different kinds of strains of HIV. This suggests that HIV has spent more time in that area of the world than anywhere else. This is a graph showing you the different strains, different types of HIV and where they're located. You can see here in North America and most of South America, we have one particular subtype of HIV-1 that's prevalent. But in places like Africa, okay, especially Central and Western Africa, you'll see that there is a ton of different strains. That's what all of these designations are over here in that area. That means that HIV has spent more time in the human population mutating and changing in that human population. So we think that that's where the virus originated from, at least geographically. To give you a little bit of background information, similar to Ebola virus that we talked about before, we think that HIV, it might have originated in monkeys. There is a virus in monkeys that's very similar to HIV. It's called SIV, or simian immunodeficiency virus. It's possible that it mutated, made a leap from monkeys into humans when the monkeys were slaughtered by humans and there was blood-to-blood contact. Even to this day, SIV that's still in monkey populations can be transmitted to humans through blood-to-blood contact, but it usually is a dead-end infection. It usually does not pass from human to human. But again, it could have been a mutation in SIV that allowed the virus to start taking hold in the human population. We think, based on genetic data, that this transfer likely happened anywhere between 1884 to 1924. The 1970s is when we really started to see evidence of HIV in the human population. It's when African doctors started seeing more cases of what they called wasting disease. The wasting disease, again, the symptoms, early symptoms of HIV, or weight loss, and things like that. So that's why they call it wasting disease. 70s is likely when HIV entered the U.S. 1981 is when it was detected in New York and California in gay men, and then also in intravenous drug users. By 1983, there were 3,000 cases of AIDS, and that's when they first started to really identify it as a syndrome. And out of those 3,000 people that were identified as having AIDS, 1,000 died. 1984, the next year, HIV was finally identified as the infectious agent, the virus that causes AIDS. And then, because HIV was finally identified a year later, 85, the first HIV test was available. 1987, the first drug used to treat AIDS came on the market. That's AZT. But again, it was only one drug, and what we found out since then is that only using one drug to treat HIV leads to drug resistance. So then finally by 1996 is when highly active antiretroviral therapy, or HAART, was implemented. This is the type of treatment that we were talking about before, using 3 different types of drugs that hit HIV at those different stages in its life cycle. And that links back up to the mortality graph that I showed you. About the mid-90s is when mortality went down dramatically. If you want more information on HIV, the background, the history of it, these are some resources for you. Otherwise, if you have any questions, remember to start looking at the discussion board for this. If you have questions, leave them for me. I can answer them right away. Also, make sure to check the discussion board for any other questions that you might have. Your question might have already been answered. Thank you very much.